Good morning to a very good morning to all of you. I am Dr. Rajiv Bhatia and I am working as HOD in Department of Civil Engineering, Mirchan Polytechnic College, Jalandhar. So today I welcome you all to this lecture series on the subject of RCC design. This subject is basically in fifth semester of civil engineering, and I'm sure this lecture is going to help the budding engineers. When we talk about this subject, there are two words. One is RCC and other is the design part. RCC word, as we all know, it is reinforced cement concrete. And when we talk about the word design, that means it is based upon certain principles of mechanics and strength of materials. So we all know that design part, the design should be safe as well as economical. So let us start with the topic and a brief introduction about the subject. So as per the syllabus of 2018 onwards, so these are the following contents which we are going to study in this semester. I'll briefly introduce this subject in the today's lecture. Then the second chapter includes the methods of RCC design. Third chapter will deal with shear and development length. There are two methods of RCC design in this curriculum. One is the working stress method and second is the limit state design method. So chapter 4th onward, we will deal with the only limit state design method. So concept of limit state method. Then we will design the singly reinforced beams. Then we will have the chapter on doubly reinforced beams. Seventh chapter will deal with the behavior of T beams, inverted beams, isolated and L beams. And eighth chapter will deal with the one-way slabs. Ninth will be on two-way slabs. 10th chapter will be axially loaded columns. Then we will have column footings. And last chapter will be on pre-stressed concrete. So if we see from the syllabus, three major components we are going to design, rather four. One is the beam, then we have slabs, then we have columns, and then we have the footing. So if we combine all these components of a building, so we are going for RCC design. So these are the some of the learning outcomes which after studying this subject you will be able to equip it with. To explain methods of RCC design, that is working stress method and limit state method. This will be covered under chapter number 2. Then we will be able to design singly reinforced, doubly reinforced rectangular beams, T and L beams as per the IS code provision. Design of one-way and two-way slabs, design of axially loaded columns and their isolated footing. So these are the learning outcomes which a student is going to be equipped with after the completion of this subject. Now, if we talk about the RCC part, which is the reinforced cement concrete, there are certain advantages of this material. It is very easy to handle and it can be molded into any shape. It can be easily made. It is durable against weathering agencies like sun, rain, wind, etc. It is fire resistant. It can bear high temperatures. It gives a good aesthetic appearance also. Impermeability is the major advantage of this RCC material. So it is impermeable to moisture. It helps in minimizing the size of the section when compared with the PCC. PCC is the plain cement concrete. If we design a section with only plain cement concrete, size of the section will be high. It will be greater. So to minimize a section, we always use reinforced cement concrete. It can be laid into difficult places with high pressure pumps. As we all know, RMC is now in. So with the ready-mix concrete, we can use these high pressure pumps to place the concrete in difficult positions. So RCC helps in making the structure earthquake resistant. So earthquake resistant, as we all know, the complete Indian geographic conditions, they are under earthquake prone areas. So we generally require earthquake resistant structures for the construction, and RCC is going to help us. Economical in the long run, initial cost is very high, but if we compare the cost in the lifespan, then it is always going to be economical. Maintenance cost is very less. Few limitations are there. Initial cost is very high. Skilled labor is required. We have to see what type of reinforcement is to be provided, how much reinforcement is to be provided, what diameter of the reinforcement is to be provided, what should be the water cement ratio, what should be the concrete ratio. Everything, a skilled labor is required. And cost of formwork is very high. So formwork, as we all know, it can be wooden or it can be steel also. So initial cost of this formwork, because this formwork is going to be kept in the RCC construction for at least 14 to 28 days. Now, these are some of the definitions of concrete. If we talk about concrete, concrete is a mixture of cement, fine aggregates, and coarse aggregates. Concrete mainly consists of a binding material and filler material. If filler material size is less than 5 millimeter, it is fine millimeters, fine aggregates, and if it is greater than 5 millimeter, it is coarse aggregate. So 4.75 mm sieve, it differentiates between fine aggregates and coarse aggregates. If you talk about the term PCC, it designates plain cement concrete. So the initial mixture of sand, cement, coarse aggregate, so a jelly type material is formed with the help of water. It is known as PCC. A small quantity of admixtures like air entraining agents, waterproofing agents, workability agents may be added to impart special properties to the plain cement concrete. Now, in addition to plain cement concrete, if we add steel bars, reinforcement in PCC, it becomes RCC. So concrete is good in resisting compressive stresses, but it is very weak in resisting tensile stresses. So it is weak in tension. Hence, reinforcement is provided in concrete where tensile stresses are expected. The best reinforcing material is steel, since its tensile strength is very high and bond between steel and concrete is considered to be very good. Since elastic modulus of steel is quite high as compared to concrete, therefore the force developed in steel is very high. So a cage of reinforcement is prepared as per the design requirements, kept in the formwork, and then green or fresh concrete is poured. After the concrete hardens, after 14 days or 28 days of curing, the formwork is removed. The composite material of steel and concrete now is known as RCC. It acts as a structural member. Now, introduction to RCC. There are certain facts which we need to understand before going to the subject. PCC is strong in compression, but it is weak in tension. Tensile strength of the concrete is only 10% of the compressive strength. So we can easily see from here, if the compressive strength is 20 Newton per mm square, only 10% will be the tensile strength. So it is very weak in tension. When load is applied on a member, both compressive and tensile stresses are induced. To make the concrete strong in tension, steel bars are introduced. So reinforcement bars are introduced in the tension portion where we are expecting tensile stresses to make it more strong to bear the tensile stresses. Steel is equally strong in tension as well as in compression. So this material is a good material which is equally strong in tension and compression. Compressive yield strength of ordinary steel bar is about 25 times the compressive strength of the concrete. So it is 25 times greater than the compressive strength of concrete. And if we talk about the tensile strength of a steel bar is 70 times the tensile strength of cement concrete. So even the tensile strength is very high. The unit weight of PCC is 24 kilonewton per meter cube and RCC is 25 kilonewton per meter cube. Now, if we talk about a structure, there are various components of a structure. This is a framed construction in which we can see the foundation part, which is below the ground level. It is known as substructure. and all the other members which are exposed out of the ground, above the ground level, they are known as the superstructure. So in superstructure, we can see the columns, vertical members, slab, which is known as the roof part, and we will have the beams in this particular structure. So combination of all these four components, we form a framed structure in RCC. So one is the component, which is foundation below the ground level. Then all these three components, they are above the ground level. They are known as superstructure. So they are columns, slabs, beams. So in this particular subject, in the complete semester, you are going to study the design of these four components, basic components of a framed construction in RCC. So in this picture, we can clearly see it is written slab over here, and all these red portions, they are slab. You can see first floor, second floor, third floor, then the top floor. And in this figure, we can see these are the beams which are hanging in red. Then we have the columns. All these red portions, they are columns, vertical members. They are the compression members, and they take the load from the superstructure to the ground, to the footing. And this is the foundation part, which is red in part. It is written over here, foundation, and it is the red part, which is showing the foundation part. Shear walls are constructed in between these members to increase the shear strength of the particular RCC structure. So it helps. It also helps in mitigating the earthquake forces which are acting over the RCC structures. Now, to understand the design part, there is a code which is known as IS 456-2000. And this particular Indian standard code, this deals with plain and reinforced concrete. So if we want to construct or if we want to design any component regarding RCC, we can take help of all the guidelines which have been laid in this particular code, IS 456-2000. And this is the link from where you can download the IS code. It's free of the cost. IIT Kanpur site is there. So this Indian standard IS means it is applicable everywhere in India, right from Kashmir to Kanyakumari or from Gujarat to Assam. This particular IS code is applicable everywhere, wherever we want to design the RCC structures. So 456 is the number which indicates this particular code, and the number which is written over here 2000, it is the year of revision of this particular code. This is the fourth revision, as we can see over here. This is the fourth revision. It was revised in the year 2000. Previously it was in the year 1978. Third revision was in 1978. Fourth was under the year 2000. Now, under this particular IS code, this standard covers the requirements of deformed steel bars and wires for use as a reinforcement in concrete for the following strength grades. Steel is available in different strength grades. Tensile strength is different for different type of grades. For example, if you talk about Fe 415 grade, that means Fe stands for the ferrous material, and 415 is the tensile strength in Newton per mm square. So we will study in the following slides what is the difference between Fe 415 and Fe 415D. This is more ductile as compared to this. Strength is going to be same, but this D suffix indicates that it is more ductile. We have to see the chemical composition. So chemical composition has been altered to make it more ductile. So we have Fe 415 grade, Fe 415D, Fe 500 grade, Fe 500D, Fe 550, Fe 550D grade, and the latest grade which has been added in this particular IS code is Fe 600. So in India, mostly the steel is manufactured up to this grade, but on special demands it can be manufactured with this Fe 600 grade as well. So the following symbol Fe indicates the specified minimum 0.2% proof stress of the yield stress in Newton per mm. And the letter D following the strength indicates the category with same specified minimum 0.2% proof stress with enhanced specified minimum percentage elongation. So in D, these three grades, the ductility is more, and the percentage elongation before failure, it is more as compared to these three traditional grades. Now, if you talk about the characteristic of an ideal reinforcing material, as we all know, the steel is being used as a reinforcing material in RCC. So there are certain characters which indicates an ideal reinforcing material. It should be easily available and cheap, high tensile strength, because this is the major criteria for deciding the steel bars in RCC works, and it should have elasticity. It should form good bond with concrete. This is very much important, because if the bond will fail, the stresses will not be transferred to the materials. So the ultimate purpose of providing these steel bars will be defied. Coefficient of thermal expansion should be nearly same as that of concrete. So as we all know, all the materials, they expand on heating and they contract on cooling. So if two materials are combining together to form a composite material, which is RCC, so the thermal expansion of or both the materials should be nearly same, so that they can expand together and they can contract together. It should be free from loose rust, coats of paints, oil, mud, etc., so that there is no hamper in the bonding process. It should be durable. The lifespan of that steel should be durable, should be long life. It should be easily cut, bent, or welded. Depending upon the situation, we should be able to cut it, bend it, or weld it, depending upon the length required. As we all know, there are so many brands which are available in the market for the purchase of reinforcing material, steel. The best and reliable brand must be used as steel, as it acts as backbone of your structure. So I always mention this thing. It is a very important part in the design of RCC structures, that your steel is acting as a backbone. So you can't replace it in due course of time. If you want to replace it after certain, let us say 3 or 4 years, so you can't replace it. You have to demolish the structure and rebuild it. But while deciding or while selecting the brand or the reliability of that particular steel material, we must go for certain tests before selecting the material from the market. We can go for physical test, we can go for chemical analysis, we can go for mechanical properties also. So there are two types of reinforcing materials which are available in market. One is the MS bar, mild steel bar, and other is the HYSD bar, which is known as high yield strength deformed bars. So as the name suggests, this is having a high yield point, and this is the mild steel bar, which is conforming to the designation Fe250. Fe stands for ferrous and 250 is the tensile strength. So Fe250 is the designation for these mild steel bars, and HYSD bars, it indicates the high yield strength, which starts from Fe415 and it goes up to Fe600. So mild steel, if you talk about mild steel, it is a general purpose steel grade, basically used for remelting, alloying, and manufacturing or fabrication of various structures. It can be used in RCC work also. Earlier it was being used in RCC, but nowadays high yield strength is being used. The steel generally made up of low carbon and silicon. The yield strength values are very low for mild steel. As I have mentioned, it is only 250 Newton per mm square. Therefore, it is not used for special purposes for reinforcing of heavy structures. So for heavy structure, we should go for HYSD bars instead of mild steel bars. Now, this is the comparison between mild steel and HYSD. HYSD bar is the high yield strength deformed bars, have ribs on the surface. Ribs are the undulations or projections on the surface, and this increases the bond strength at least by 40%. These are made of different grades and type, as I have mentioned: Fe415, Fe500, Fe550, and Fe600 grade steels are mentioned in HYSD bars. So mild steel contains low carbon content, whereas HYSD is the high yield strength deformed bars. It contains more carbon. So as we are increasing the content of carbon, we are getting more hardness, more strength, but on the same side, the ductility is getting decreased. So mild steel strength is low, but they are ductile, easy to shape, and more weldable. Whereas HYSD bar is used where tensile strength requirement is high. For all the heavy structures, for reinforcement materials, HYSD bars is preferred. So HYSD bar is more brittle depending upon the carbon content. So as we go on increasing the carbon content in steel, it becomes more brittle. So if it becomes more brittle, that means it is not having the proper ductility and elasticity property. So we have to take care for that also. So these are the two pictures which clearly shows the mild steel bars on the top, and these are the HYSD bars. So what is the difference between these two bars? We can clearly see that these bars are plain bars. They don't have projections. And in this picture, we can clearly see the ribs. These are the ribs. These, and you can see the ISI mark also. So all these steel bars, they are considered to be good if they are possessing the ISI stamp on them. So good companies, they are providing these ISI mark along with the grade of the steel and the IS code depending upon which they have manufactured that particular steel. So we can see from these two pictures that mild steel bars are the plain bars and HYSD bars are the bars which are having projections and they are having more yield strength as compared to mild steel bars. Now, this is the figure which is clearly showing one of the brand which is available in market. This is Tata Tiscon, a good company which is manufacturing steel. And this is the grade of steel which is mentioned over here. So on every bar, HYSD bar, these grades, the company name along with ISI stamp is mentioned on every meter of that particular length of bar. So we can check it depending upon physically verification of this particular brand that we are going to choose the best material out of all the materials available. Now, if we talk about the reinforced steel, as I have mentioned, it is represented by yield strength of the steel. Yield strength is the point before failure. Before it fails, this is the point which is achieved. It is known as the safe point, or we can say it as a yield strength of the point of the steel. So specified strength as designated earlier also, mild steel conforms to Fe250. It is very less commonly used because of their low strength. It is only having 250 Newton per mm square of tensile strength. Whereas if we talk about HYSD bars, it goes from 415, it goes up to 500, 550, 550, and even now 600 grade is being manufactured in India depending upon the special demand. Then we have a bar which is known as thermomechanically treated, TMT bars. We always hear this name TMT whenever we go for the reinforcing material. So steel bars are thermomechanically treated. This is a process which is used in the manufacturing. Depending upon this process, the inner core of the steel bar is kept as ductile and area outer periphery, this is of high strength and it is anti-corrosive coating also. It is having an anti-corrosive coating on the outer surface of the outer periphery of the circumference. So in one bar, we are getting two properties. One is the ductility, which is providing by the inner core, and the high yield strength, which is provided at the outer side of the steel bar. So these steel bars, they are generally manufactured in different diameters, ranging from 5 mm to 50 mm. Generally, the steel bars which are being used in the site for the construction is 8 mm, 10, 12, 16, 20, 25, 32, so on. Now, there are different grades of TMT bar as I have mentioned over here. All these grades, they are manufactured nowadays. They are conforming to the IS specifications 1786 2008, and this table shows the yield stress, the stress which is considered to be the proof stress, 0.2% of the proof stress. So it is in Newton per mm square. So if we talk about Fe415 grade of steel, it is having 415 Newton per mm square of the yield stress. For the Fe415D grade, it is the same value, 415. For Fe500, this is the 500 Newton per mm square. And for Fe500D, this is again 500. So what is the difference between Fe415 and Fe415D? Both are having the same yield stress, but they are having the different percentage of elongation. So I'll discuss it in the coming slides. What is the difference between the values of different grades of steel? Now, in this in this table, we can clearly see some of the mechanical properties of some typical reinforcement used in India, IS 1786. These are the grades, Fe415, Fe500, then Fe500D. This is the elongation in percentage. So for 415 grade, we are having 14.5 mm of the percentage elongation. 14.5% of elongation. Here we have 12% and here we have 8% of percentage elongation. So that means as we go on increasing the strength of the steel, the percentage elongation is decreasing. So that means because of the high content of carbon in the higher grades, the value of percentage elongation, it goes on decreasing. So mild steel is having Fe250 strength, but it is having a percentage elongation of the range 20 to 22. So it is having the highest ductility, but as we go for HYSD bars, depending upon the grades, the values of the percentage elongation that goes on decreasing. Now, these values of percentage elongation, they depend upon the chemical composition of HYSD bars. As we can clearly see, these are the grades of the steels. These are the chemical constituents. We have carbon, we have sulfur, phosphorus, and this is sulfur and phosphorus in combination. They are individual and this is in combination. So as we can see from these first two columns, Fe415 and Fe415D, what is the difference between these two bars? They both are having the same yield strength, 415 Newton per mm square. But if we compare the carbon content, we have more carbon in Fe415 and less carbon in Fe415D. So from complete table, you can compare that in all the cases, if we go for the D specified bars, they are having the lower percentage of these chemical components, which make them more ductile and elastic. So this particular chemical composition, this helps in deciding the grade of the steel and the percentage elongation of that particular bar. Now, as we all know, this is the universal testing machine, which is used in labs for testing the materials. The name universal means it can test 3 or 4 tests can be performed on this particular machine. We can go for tensile strength test. We can go for the bending test. We can go for the compression testing for the cubes, RCC cubes also. Now, if you talk about the tensile strength of the steel, this is the steel bar which is held in the jaws and the tensile force is applied in the opposite direction, in the outward direction. These are the gauges for measuring the percentage elongation. And we can clearly see that a steel is the only material, which is the ductile material and elastic material, which gives a particular warning and time before failure. So as we go on increasing the load, a neck is formed over here, the length is increased, the diameter gets reduced, and finally a neck is formed and the ultimate failure takes place at this particular point. So that means before failure, steel is a material which gives certain warning. So that's why it is very much required in RCC structure, and especially the structures which are going to construct for earthquake resistant zones. Now, these are the stress strain curves for these particular steel grades. We can clearly see this grade, this bar, this curve is for mild steel, and these two curves, they are for HYSD bars. Now, if we compare these two curves, we can clearly see that for mild steel, we are finding a point over here, which is the elastic limit point. And up to elastic limit, after elastic limit, this is the plastic limit, and this goes for the plastic pool, and this is the point from where we can't control the failure of the steel. So if we are within the elastic limit, then the steel is going to come back into its original position, original shape, and original size. But if we go for instead of elastic, we go for plastic limit, then there is going to be some permanent deformation, but the failure will not take place. But if we cross the plastic limit, then the failure can't be controlled. It is going to fail definitely. But we are getting a peak value up to here, but the failure yield point is considered to be here only. It is 250 Newton per mm square. A clear point of yield is noticed in this mild steel bars, but for HYSD steel, Fe415 and Fe500 steel, we can clearly see there is a graph which is going up to here and it is getting flatter over here. No such peak point is noticed in these particular steel bars. So to get the yield point, we generally go for 0.2% strain value, 0.2%, 0.02% of the strain value. So depending upon this line where it crosses these points, these are considered to be the yield point for Fe415 and Fe500 steel. So the strength values are very high in case of HYSD bars, and the value of mild steel is very low as compared to these two bars. Now, there is advancement in technology in the steel rebar manufacturing. Many type of bars, they are being manufactured. These are the two major companies. This is the public sector company, Steel Authority of India Limited, and this is a private company, which is Tata Group. So this is Tata Tiscon. So these two companies, they are the major players in the reinforcement manufacturing. And there are so many other brands also available in the market, just like Kamdhenu Steel. Then we have uh, so many type of steels, they are present in market. So if we talk about the advancement, new technology which is coming out into TMT rebar, Tata Tiscon has designed a technology which is known as SD, which is super ductile. So buildings and infrastructure in seismic zones, earthquake zones, they have to be better prepared for earthquakes, so have special criteria for reinforcement. So Tata Tiscon SD. So in all the steel bars, they have mentioned this SD as a stamp on over their reinforcement bars, and are special grade rebars from Tata Steel and are particularly suited to meet these requirements. Its superior property provides extra safety to the construction in frequent earthquake zones. So, as we all know, the complete India has been divided into 4 earthquake zones. So, Punjab is in zone number 4 as per the latest guidelines. So, we have to take care, especially extra care, while deciding the reinforcement which is to be provided in RCC structure. So this Tiscon SD, it is available in the sizes 6 to 32 A comparison chart of the specification of Tata SD has been mentioned here. So this is the source from where this slide has been taken. You all can go through this particular website, this link, to get more information. So this is the chart which has been shown by Tata Steel, and it is going to be benefited for the budding engineers. These are the mechanical properties. This is the BIS, Indian Standard 1786, depending upon which HYSD bars are being manufactured. This is the UK standard, this is the Australia and New Zealand standard. And this is the Tata Tiscon SD, the values which have been obtained by this particular brand. So if we talk about the yield stress minimum, if we go for Fe500 steel, it is 500, Fe500B other standards. So FE 500 SD, the brand which has been manufactured by Tata Steel, it is even giving 500. So this is the minimum yield strength. If we talk about the maximum yield strength, it goes up to 650 Newton per mm square. So same steel is giving maximum yield stress. If we talk about the ultimate tensile strength minimum, it is 8% higher and it is giving 15% higher. So ultimate tensile strength and divided by yield stress ratio. If we see, the standard is mentioning that it should be 1.08. All other are giving these standards, and even Tata Steel is giving better than that particular value. So percentage elongation is 12.2, which is designated in this particular IS code, but it is under 16 millimeters. It is up to 16 millimeters of percentage elongation. So it is a higher value as compared to, it's a good indication that we are getting a total percentage elongation of 16% with 500 SD. Now, if you talk about the second type of technology, this is the plasma rebars, which have been manufactured by Tata Tiscon, a cutting edge technology from Tata Tiscon. This technology is patented. Patent has been obtained for electrolytic plasma technology. So this is the technology which is being used to manufacture these type of bars. So plasma rebars are coated with zinc and treated with additional surface passivation of higher resistance to corrosion. So corrosion is a major harmful property in steel. So we have to protect it from corrosion. So this type of technology can help to mitigate the atmospheric environment agencies which are acting over these particular bars. So coating does not peel off the exposed rebar surface, and prominence of ribs are maintained even after the coating. So weldability and bendability, which are the two major requirements of an ideal steel bar, they can be easily done with this particular technology also. So this is a pictorial view. This is the steel bar, cross section of a steel bar, and we can see this green portion, which is the coating, which is provided the zinc protection to protect the rebars inside the concrete. So when this rebar, this steel bar is inside the concrete, so the moisture content, the chemical reaction, they all are acting upon the steel bar. They are coming in contact with steel bar. So that's why this coating helps in mitigating the corrosion property. Corrosion can be prevented on the steel bar. Now, if we talk about the different type of loads on structures, while designing, we have to calculate all the types of loads which are coming over the structure. Only then we can decide what is the section of the member which is to be casted, what type of reinforcement is to be provided, what diameter of the reinforcement is to be provided, what are the number of bars which are to be provided to take that particular load or stress. So these are some of the loads which are acting over a structure. First is the dead load. The self weight or self load of the material of the building is designated as dead load. So it is not going to change. Once you have constructed the building or a structure, the dead load is not going to change. It will remain same because all the materials, they are going to stay there for the lifespan of the building. Second category of the load is the live load, which is also known as the superimposed loads. So superimposed, as the word is indicating, superimposed means when we are imposing certain loads over that particular member or over some structure, they are known as the live loads. So live loads can change depending upon the occupancy of the building, depending upon the number of persons which are living in that particular building, or depending upon the usage of that particular building, for what purpose it is being used. Then comes wind load. The wind intensity, it generally goes on increasing as we go for the higher structures. At ground level, we can't see the wind pressure, but for the high rising structure, it is very much important to calculate the wind loads. Then snow loads. So for example, in plain areas like Punjab, we don't have snowfall, but the areas which are there, let's say Leh Ladakh or J&K, where the rainfall is heavy, where the snowfall is heavy, so the snow is over the structures for a longer period, then we have to calculate the snow loads also for that particular calculations. Seismic loads or earthquake loads are the most important loads which are to be calculated in a building while calculating the loads, because you can't predict earthquake. This phenomenon, this is a natural phenomenon, it can't be predicted. What is the place, what is the time, what is the intensity on Richter scale, we can't predict it. In which direction it is coming, even that can't be predicted. So that means we have to be prepared for all these earthquake loads on a structure. So we have to take care all these loads. Last is the impact load. Impact load is any sudden load which is applied, just like earthquake is acting, so it is an impact load, kind of impact load on the particular building. So combination of all these type of loads which are coming over the structure, they are to be considered while calculation of the loads and while designing the members of a framed construction, which are the four major members I have discussed earlier. We have the substructure, which is the foundation part. Then we have the vertical members, which are the column parts. Then we have the horizontal members, which are the beams and slabs. So while calculating all these loads, special care has to be taken. All different combination of the loads must be formed, and the building should be designed for the critical combination of loads. Now, this is the IS code, and these are the titles. IS 875 Part 1. This particular code deals with the dead loads. So all the materials, all the building material, they have been covered in this code to calculate the dead weight of that particular member or that particular structure. So part 2 of 875, this is the imposed loads. All the live loads, they have been covered in this particular part 2 of the code. Then similar IS 875, this gives the guidelines for wind load. Part 4, snow load, and part 5, these are the special loads and load combination. So that means this IS 875 code, this helps in deciding and calculating all the type of loads which are coming over the building for the design of RCC members. Now this is the code of practice. This is the pictorial view of this IS code, IS 875 Part 1 1987. So Part 1 deals with the dead loads, unit weights of building materials, and stored materials. So in this slide, I have shown certain materials, some of the materials with their unit weights. For example, brick ballast. Brick ballast is the small pieces of brick which are being used in the flooring. So this is having a unit weight of 8.85 to 14.3 kilonewton per meter cube. It's a volume, meter cube. So this is the weight, unit weight of this particular material. If we are putting brick ballast on, let us say, first floor, then we can easily calculate what is the volume of the material which we have placed over the roof and what is going to be the load, dead load for that particular member. Then brick burnt, clay bricks, which are burnt bricks, they are 15.70 to 18.85 kilonewton per meter cube. RCC 25 kilonewton per meter cube, and steel is 78.5 kilonewton per meter cube. So volume, and this is the weight. Marble, this is the flooring material. So flooring material, we can clearly see this is 26.7 kilonewton per meter cube. We can clearly find the volume of a particular marble piece depending upon the thickness and depending upon the size of the material which have been used. And depending upon that, we can easily calculate what is the load which is coming over that particular structure. Even for wood, we can see the deodar tree, it is having a density of 5.35 kilonewton per meter cube. And timber sal, it is a good wood, hardwood, so it is 8.5 kilonewton per meter cube. So these all values, they have been mentioned in IS 875 Part 1. So many materials, all the other materials which you can imagine, all these materials have been covered in this particular standard to see what are the dead weights of that particular material. Then comes the live loads on this structure. This is covered under Part 2. And we can clearly see, depending upon the occupancy of that particular building, we can decide what is the live load which is coming over the slab, over the beam, or over the column. So floor loads for residential purpose, it is up to 2 kilonewton per meter square. For office, we have more people, we have more furniture, more infrastructure, the weight, the load goes from 2.5 to 4.0 kilonewton per meter square. The units are meter square. So classroom, we can see we have so much furniture, students, their bags, everything. So if the class is on the first floor, we can easily see what type of live load is going to come over that particular roof or that particular slab. So garages, even more load is required. We can park the vehicles. We have to mend those vehicles. We have to sell those vehicles. So that is of the range 4.0 to 7.5. So as we can see clearly, the residential structures, they have a very less live load. But as we go for public buildings or the garages or the warehouses, the load goes on increasing. So roof load, if it is access is provided, you have provided the stairs and it is accessible, it is counted to be 1.5 kilonewton per meter square. And if you have not provided any access to that particular, it is considered to be 0.75. These are all the type of load combinations, all type of live loads, which are depending upon the occupancy. You can easily see what floor load or live load you have to decide. So this was all about the introduction part of the first chapter. This is first chapter in your syllabus of RCC design. So if you have any queries, then you can email me at this email ID, or any suggestions or any comments, you can please write me on this mail ID. Thank you so much. So you have a wonderful day. Stay home and stay safe. Because of this coronavirus, the physical classroom is not possible nowadays. So we are thankful to Government of Punjab, especially our Captain, Honorable Chief Minister Captain Amrinder Singh, who has taken initiative under Mission Fateh to safeguard us. They have mentioned certain guidelines which we have to follow to keep ourselves and our families safe from this coronavirus. So stay home and stay safe. Thank you so much.